Okay, in the last example, we did a means comparison involving only one variable, which was either average class size or the number of students that a teacher worked with in a day for one group, all the teachers in these 5 districts. Now we're going to move to a second type of t-test, and I want you to think back to our little flow chart, our logic model. I'm going to ask you, is there a mean difference? That word difference cues me into a causal comparative research design, so I know I'm going to compare means. Is there a mean difference in the number of hours a day spent with a classroom aide, which is labeled Q6, between male and female teachers, which is Q31, just gender? So what I'm saying is, how many groups do I have? I have male and female teachers, 2 groups, independent of one another, and I have one dependent variable, number of hours a day they have a classroom aide in their classroom. So I have 2 groups, 1 variable, so I know I'm going to run an independent sample t-test. So I go back to my Teacher2 database, and I go to Analyze, Compare Means, and I scroll down to Independent Samples t-test. My test variable is going to be Q6. You can see how far down it is. Hours a day with an aide. I'll move that over. Then my grouping variable is going to be Q31, which is what is your sex, what is your gender. And it's going to tell me to define those 2 groups. This is where I would need to go back and look at the value labels. I know that gender in this database is coded as 1 or 2 for male and female, so I'm just going to enter 1 and 2 there, and I'm going to do OK. But before I interpret the chart, I'm going to flip back to where I was at and go to Variable View, and I'm going to scroll all the way down to Q31, and I see gender, males were 1 and females were 2. So I was correct to add it that way. So I'm going to go back to my output, and let's talk about a couple of things here. I want to know if there's a difference in the number of hours a day. Teachers have an aide. Male teachers and female teachers have an aide. So there were 156 male teachers in the sample, and they have an aide 0.61 hours a day, and females have it 1.35 hours a day. So 1.35 minus, or 0.6 minus 1.35 gives me my mean difference. And I want to know if that mean difference is far enough from 0 to be considered statistically significant. But before I do that, there's an assumption. And that assumption, when you ran a t-test, and remember, this doesn't change results much, but to be technically accurate, you need what's called equality of variance or homogeneity of variance. So I go for that test and I run Levine's test for equality of variance. And I look at that significance. If that significance is less than 0.05, I reject the null about equal variance, so I cannot assume equal variance, and I read the second row. If this number was greater than 0.05, I can still assume equal variance, and I would interpret the top row of numbers. So all this is doing is saying, are these variances between these 2 groups equals, so that I can really compare these means? And if they're not, it runs a little bit more of what's called a conservative test. makes it a little bit more difficult to reject the null most of the time.